Hi. So in the last video, basically we cover uh, starting from relationships. We define what is function and then what is domain, what is range, identify the domain and range, how to write the intervals and so on. So today we will look into the idea of composite functions. So if let's say you have a function f which maps from x to zy, so as shown in the figure above. So G maps from Y to Z. So then you can define a composite function that maps from X to Z such that h of X is given by G of F. So over here, f of X is in Y. And then the whole thing, the G of X, G of f of X, this one is in Z. So remember that when you write the composite function, you always operate from right to left. So this is a direction of operation. So the first function that you operate on has to be written on the rightmost. The last function that you operate on will be on the leftmost. So this is a direction of operation. Okay. So that is on the notation. And then in general, if you have G of F, this is not the same as F of G. There are some exceptions, but in general, this is not true. And then the second thing is when you have F square of X, this is actually F composite with F. And then the third thing, when you look at this particular diagram, I also label out. So from this particular diagram, you can see that the range of F is the domain of G. So in a way, your domain of GF, your domain of F will be the domain of GF. Your range of G will be the range of GF. So those are the things that you can notice from the diagram. Let me okay. So now let's look at some examples. Find f of G and G of F of the following. Functions. So the first one, if f of x is 2x minus 1, g of f is 3x squared. So f of g will be f. So g is, sorry, this is g. So this will be f 3x squared. And then f is 2x minus 1, so you substitute inside. So you have 6x squared minus 1. So if it is g of f, your f is 2x minus 1, and then your g will be 3x squared. So from here you can already see that in general f of g and g of f are different. Okay? So the second example, perhaps we can look at, let's say f of x is square root of x. G of x is 2x minus 1. So f of g be f 2x minus 1. So then this will be the square root of 2x minus 1. If you have g of x, this will be g. Fx is square root of x. So then you have 2 square root of x minus 1. The third example, let's say f of x is 1 over x. G of x is this whole thing. X plus 2, x minus 3, 1. So f of g will be f of the whole thing and then you reciprocate due to f of x, so you get x plus 2, x minus 3. Second one, g of f. So this will be g of f, which is 1 over x. So this will be 1 over x plus 2, 1 over x minus 3. So now you can factor out 1 over x twice. So then the first term you have 1 plus 2x. Second term you have 1 minus 3x. So finally what you will have is 1 plus 2x, 1 minus 3x. This is x squared. So of course, given the composite functions, I can also, for example, let's just test with the third one. So let fx to be equals to 1 over x. And f of g is x plus 2, x minus 3. Find gx. So what you would do in this case is you define f of g as x plus 2, x minus 3. Then over here, f by itself is 1 over x. So you can treat gx as some elements and then use the definition of f of x to write this. then automatically speaking your g of x will be recovered, because this will be x plus 2, x minus 3, 1. The other way around, we need to define what we call as the inverse function first. So let's define what is an inverse function. So for inverse function, basically it's more or less the same thing. So by the name that you can roughly understand that inverse function basically is the opposite direction of f. So let's say you have two sets, x and y. So if the forward direction is mapping from x to y, the inverse function of f will be mapping from y to x. So if f maps from x to y, then f inverse maps from y to x. So there are one thing that you need to take note of. The first thing is the domain. So this is very important. The domain of f will be the range of f inverse. The range of f will be the domain of f inverse. So this is a very important fact. So that's the first thing. Second thing is that your function f needs to be 1-to-1, so that the inverse can be defined. So for example, previously we talked about what we call as the vertical line test, that tells you whether or not that is a function. So now we have what we call as the horizontal line test, whereby this will tell us whether or not the function is 1-to-1. So let's look at the simplest one, some quadratic equations. So we know that this particular quadratic equation satisfies the vertical line test. Because at each instances, your vertical lines only intercepts at one point. But if you draw a horizontal line, it will intercept at 2 points. So this is what we call as the horizontal line test. So if the function is 1-to-1, all horizontal lines must pass through the function at only one point. So if it is one-to-one, then it also implies that you have an inverse. So horizontal line test usually is being used to test whether or not your function has inverse and at which range that your function has inverse. So how do we fix this particular function, for example, if we want it to have inverse? You need to restrict your domain in such a way that you either have the left path or you have the right path. Let me use dotted line. So either way, if you define your function to only have half of the path, then any horizontal line will only intercept at one point. For example, if you have this particular horizontal line, it will only intercept the solid line at one point. Or if you define the dotted lines to be the function, then you only intercept the dotted line at only one point as well. So that's how you need to do to sort of like make your function to be one-to-one. You restrict your domain. So this is what we call as restrict the domain. Restricting the domain so that the function is one-to-one. Okay. So over here, obviously you can see that F composite with F inverse will be equals to F inverse composite with F, and this is X. So now let's look at some examples. Find the inverse of the following. So let's say your fx is 2x minus 3. So usually the procedure of finding inverse is to let fx equals to y first. Then your inverse of y will be x. So y equals to 2x minus 3. So then the purpose is to find x. So 2x will be y plus 3. X will be 1 over 2. Y plus 3. So x is f inverse, therefore f inverse of x. So now you exchange back your x and y. Will be 1 over 2 x plus 3. So let's look at something more complicated. let's say f is one plus 2x, x minus 1. You need to find the inverse. So similarly, first step, let fx equals to y, then f inverse of y will be equals to x. So y equals to 1 plus 2x over x minus 1. So xy minus y equals to 1 plus 2x. So then xy minus 2x equals to y plus 1. So factor out your x. You have y plus 1 divided by y minus 2. Therefore, your f inverse will be x plus 1 over x minus 2. So now let's continue with the example as before. Just now, notice that what I gave you is one of the function and then the composite function, and the function that I give you is on the outside. So now if I do the opposite, so I give you, let's say fx equals to 3 over x. And the function that I give you is on the outside. Sorry, not on the outside, but on the inside. Wait, where is that? Okay, perhaps let's do this. So fx is 2x minus 1. G of f is 3, 2x minus 1 square. So find gx. So what you need to do is to first find the inverse. Then so we already know that x is 1 over 2, y plus 1. So f inverse is 1 over 2, x plus 1. So the point here is that your g of f composite with f inverse will give you g of x. So therefore, what you need to do on the left side is to composite g of f with 1 over 2 x plus 1. So this will be 3, 2, so x will be 1 over 2 x plus 1, right? And then minus 1. So these two will cancel off. And then you have 3 x plus 1 minus 1 square, which is 3x squared. Therefore, g of x is 3x squared. So that's how you find your function g when the function that the question gives you is on the inside of the function. So finally, what you need to take note is that the graph of, let me F inverse is the reflection of F at y equals to x. So let's say this is a quadratic equation. So let's say this is f of x. So if you want to sketch the graph of f inverse, what you need to do is to, sorry, not this line. Draw a line that represents y equals to x and then reflect it. So after the reflection, it should be something like this. Okay? So this will be f inverse. That's how you sketch the graph. This is y, this is x. I think we can stop here for now. So let's continue on in the next video. Thank you.